All right, so we talked about product and quotient. Let's do chain rule today. And maybe implicit, we'll see. All right. So the first few are more of a conceptual questions. I think the easiest way to understand this is to remember composite functions. This is 3.4. So basically, suppose you have, you have two functions. F and G that are differentiable. Meaning you can take a derivative without any problems, right? There are functions where you can't. So let's say y of x is equal to a function composed with g. So basically, you remember the composition in college algebra, right? Back in the day, fog was fog of x was f of g of x, right? So given this composition, the derivative of y, derivative of this composite would be the derivative of the outside, leaving the inside alone, times the derivative of the inside. That's how you find, this is the chain rule. And if you have multiple composites, meaning f of g of h, like function within a function within a function, then this chain will grow. Obviously why it's called a chain rule, right? To have, let's say you had three functions. We have f prime g of h times g prime times h prime. If you have a really strange looking function, that could happen. Okay. Now, so these top questions are conceptual. I'll let you deal with this. Number 5 and 6 is where you start doing the composite stuff. So you need to identify, looking at this, what is the inner function, right? What is the outer? Okay. So I'm going to relabel this. Example 1 is find the derivative. Okay, switch over. Find the derivative of, I'm going to relabel it as y equals 2 times 5 minus 7x to the 5th. Okay, so y equals 2 times 5 minus 7x to the 5th. So the outer function, the f, is 2x to the 5th. The inner function is this 5 minus 7x. Okay. So what you do, the derivative, you do the derivative of the outside, you bring down the 5, just ignore the inside, 5 minus 1. And then you multiply by the derivative of the inside. So this becomes 10, 5 minus 7x to the 4th. Derivative of this will be a negative 7. So this becomes negative 75 minus 7x to the fourth. You see what's happening? So derivative of the outside, right? That's the formula. This is the outside times the derivative of the inner function times derivative of the inner function. Any questions on this first example here? Okay. Look at another one. Let's look at this weird square root function. Find y prime. So I'm just going to shorten it up and keep using y just because it's simple. So the y they're giving us is the cube root of 6x squared plus 7. So the outer function f is the cube function, right? The inner function is this inside part. So before you start, you got to kind of change this to a power, right? So now you start the derivative. So do the outside first. Subtract by 1. So this is just a basic power rule. Power rule for the outer function. And then times the derivative of the inside. So I'm not doing it all at once. I'm just showing you the quote meaning derivative of the inner part. So that becomes 1/3 times a negative 2/3 times derivative of this will be 12x. This first few steps make sense to you. It's following the chain rule formula. At this point, just do some algebra and you're done. 3rd times 12, that's a 4. Bring that to the bottom, that's 6x squared plus 7 to the 2/3. The negative power brought it to the bottom. 1/3 times 12 is 4, and the x is right there. Any questions on this example? Is the calculus step clear here? Is the algebra clear? All right, so sometimes you'll have to do, so as a chapter, to go further in the chapter, you're gonna have to do all the rules at the same time, basically. So there might be a product rule, and during the product rule, you may have to do a chain rule, and then during that chain, you might have a quotient. So you could, it is possible to have every rule all at the same time. I'm not saying I'm going to give you stuff like that, but it can happen. So make sure you understand when you see a specific scenario, you know which rules to apply. Okay. So on the next example, it's gonna be a product, but during the product, you're gonna have a chain. Or you don't have to write y of x, but I just do it just because. Okay, so the derivative. Technically, we have a chain, so it's going to be the derivative of the first part times the second part plus the first part times the derivative of the second part. So the chain rule says to do. So I'm going to show each step. Derivative of x squared is this guy times the second function plus the first function times this derivative. So right here, you're going to have a chain. So it changes to a 1/2, and you're going to get 1/2 9 minus x squared 1/2 minus 1 times 9 minus x squared derivative. Any questions from the beginning of that product rule step, and then when the chain rule triggers here? Okay. Oh, let's just finish it up then. This would be 2x square root 9 minus x squared plus x squared times derivative of this will be negative 2x. So we'll multiply all this. 1/2 minus 1 is a negative half, 2x negative. This point, we just gotta simplify. So the 2.5 will cancel. This thing is going to be negative. This will be on the bottom. So this will be minus x cubed over square root 9 minus x squared. Once you multiply all this out and bring this to the bottom. Any questions on that algebra or calculus step? You see how they can get more and more ridiculous, right? If they start throwing in a combination of rules. Like as you can see here, this would be a quotient while you're doing a chain. This is a product rule, and then a chain shows up. This would be a quotient with a chain. Let's do this guy. But I'm going to change the t's to x's. Technically, we should get a common denominator. So if you multiply this guy by square root 9 minus x squared over square root 9 minus x squared, we can add these fractions. So that'll be 2x times 9 minus x squared, because these will become 1 power instead of square root power. This will become, it's still the same, but now you can combine them. Distribute this guy here, that'll be 18x minus 2x cubed minus x cubed. Combine the fractions. So that'll simply become 18x minus 3x cubed over this garbage. Double check. Yeah. You guys cool on example 3 then, right? Nothing strange or is it difficult? Is it weird? Please let me know. If not, I'm moving on to another one. Okay. Problem 13. That's one. 11. This is 5. This was 8. All right. That was it. Garbage milk. Good. On 13. So h of x is equal to x cubed over x to the 6 plus 7 squared. So the derivative will be, bring down the 2, leave the inside alone, subtract 1. So the outer part is just a power rule, and then multiply by the derivative of the inside. So now notice as I'm doing the inside, it turns into a quotient. So this would be 2x 2x cubed right here, over x to the 6 plus 7. It becomes a single power. I'm going to put brackets because this is going to be a quotient. Quotient rule says you square the bottom, right? Right there. And you do derivative of the top times the bottom minus the derivative of the bottom times the top. Let me double check something. I'm always paranoid on the quotient. Here it is. Minus f prime, yeah, g f prime. Okay. All right, so now algebra time. No, I guess we got to do that derivative first, but this 2 just show there for now. Derivative of x cubed, that'll be 3x squared times x to the 6 plus 7 minus this derivative will be 6x to the fifth plus 7. 7 will be 0 because derivative constant is 0. It's gone. And then there's this x cubed chilling right here. Okay. X to the 6 plus 7 squared. Okay. Now it's algebra time. It's calculus step. Okay. These 3 lines here are the calculus part. Okay, I'll keep going then. So this will be 3x cubed times garbage will be 3x to the 8 plus 21x squared minus 6x to the 8, right? Over this square. Now just FOIL this or distribute the x cubed on every single term. Come multiply these two together, and we'll be done. Finally. So on the top, we will have 3. So x cubed times x8, that is x11. X cubed times x, that is 5. And that'll be 11 again. I should have combined those two. They're the same. If I combine them, that'd be 3 minus 6 would be -6. So there you go. You can skip that step. You could distribute the 2, I guess. I don't know. You want to multiply everything out, you will get this. It looks like they left it factored. Oh well, who cares? Anyway, that's pretty much the chain rule. They're gonna ask the same questions at the end, like slope of the tangent line. Well, that just means take the derivative and plug in that x value. And then there'll be trig functions that also require chain rules because now you have a function inside the cosine or inside the sine. It'll be exactly the same. Just remember the derivatives of trig functions. You guys have any questions on the quotient? I'm sorry, the chain rule. That makes sense? Let's move on to implicit then. If we do extras today, maybe we can have a chill day next week or something. Okay, so implicit, you're gonna have to use this notation, the dy dx. The quotes, primes, or whatever, it's not gonna be helpful here, so we're gonna not use that anymore. Okay, so this is section 3.5. And this becomes very useful when it comes to applied problems. So applying these ideas, which will be next week. So just remember the book starts to assume at this point that you can do a quotient, product, power rule, no problem. Okay. And if you're still struggling with those, make sure you practice, okay? So the best way to learn this is with an example. Find dy dx by implicit differentiation. So far we've been taking derivatives with respect to only one variable. Notice how we have an x and a y now, but where they want us to derivative with respect to x. So if you do a derivative with respect to x on a y, that's when the implicit step happens. So this is how I want you to think about it. Space. Okay. So what you're gonna do is take the derivative, because they want dy dx. So do the derivative with respect to x of both sides. Derivative of any constant, no matter what, with respect to any variable, doesn't matter. It's going to be 0. So this guy will be 0. So what you're gonna do is do derivative of each term. One second. Okay, sorry. So derivative of this guy, see how they both match? It's x and x. So you're gonna treat this just like all the other examples, same approach. Bring the 2 down, subtract 1. So nothing has changed for this. Would be 6x. This doesn't match. This is an x and a y. So what you're gonna have to do is treat it like you would an x, but then add an extra part. So you're gonna do 7, bring down the 2, subtract 1, and then times the implicit part. So add this extra step. So if you do a variable that doesn't match, tack on this chain rule, dy dx. Does that make sense? So the implicit derivative is done. So at this point, they said find dy dx, so isolate this and you'll be done. So I'm going to subtract 6x over. Divide both sides by -14. -14y. Yeah, let me show that in the next step. Otherwise, it looks messy. There we go. So these will cancel. So now dy dx is equal to positive 3x over 7y. So the derivative with respect to y will be this implicit function. Implicit meaning that you can't isolate x or y. It's going to have both parts. So you do your implicit derivative first, then isolate dy dx. Are there any questions on the idea of implicit? Okay, let's do one more, because honestly, this section is going to be the exact same thing. So the concept is just doing this step here, and then solving for dy dx. So product rules, chain rules, all that stuff, quotient rules is going to apply here. So right here, these will be product rules, but during the product rule, you're going to have a chain. I'm sorry, a implicit step. Okay, so it's the same thing. As the last few sections, just add that implicit step. This is a new extra step. Whenever it's implicit, do it this way. Okay, so let's do one more and then we'll call it, because I'm pretty sure everybody's tired. Find dy dx by implicit differentiation. I feel like my handwriting is getting worse and worse as I get tired. Okay, 7x squared y plus 2y squared equal to -1. So do d dx, this is dy dx, right? Yes, so d dx, if it would have said dx dy, you would have d dy here. It would be the same, except you hold, just remember the ones that match are treated the same as before, and the ones that don't match, you add that implicit part. Okay. Just think of it that way you don't have, it won't matter what letters you see, it'll be the same thing. The d dx on each one. This, you notice that this is gonna be a product. So this will be 7. Uh, 7 derivative times the y plus 7x squared times the y derivative plus another chain rule, 2y squared derivative times the x plus 2y squared times the x equals 0. So I'm doing a chain rule for this part here and for these two. The chain is coming, or sorry, product rule is coming from here. And of course, this right hand side is just 0. So derivative of this. Now remember, I used the quotes here. I shouldn't have, but it's just to save space. I'm running out of space. Just remember that it's respect to x. So if I'm doing derivative on x, you treat it the same. Derivative on y, well, that's going to be dy dx, which is the same as y prime. Plus derivative of this guy will be 4y times dy dx times that x right there. Forgot to put a quote over here. Plus 2y squared times 1. Okay. So now move everything that doesn't have a dy dx to the right hand side. And then factor dy dx and solve for it. Okay, so I'm going to keep everything that has a dy dx on it. Subtract everything else. Okay. Okay. So factor dy dx. You'll be left with this garbage right here. Divide this out. And you'll have dy dx solved. These are gone. So dy dx derivative is equal to this right here. So this is going to be a little algebra intensive, not as bad as the last section, but just depends on what type of derivative you're doing. Okay. Any questions on the implicit derivative? Well, we'll stop the lecture here then. Do you have any homework questions or any issues you're having? You guys doing okay on your homework? Is concepts okay? I haven't graded exam 1 yet, by the way. I think that either it's about to close or close a bit ago. I don't remember, but pretty sure it closed.